right, so today this is going to be topic 11.6, normal distribution. All right. And so these three diagrams are of how some data is distributed. And the first two are skewed. And data is skewed on the side that it's too short, if that makes sense. So if you're looking at this first one, is it too short on the positive side or too short on the negative side? The positive side. So this one is going to be positively skewed. Right, and then the second one is too short on the negative side, so it's going to be negatively skewed. Right, and then the second one is not, or the third one, sorry, is not skewed at all. So there's the most items in the middle, and then it kind of goes down. That is called normal distribution. And so normal distribution is a symmetrical bell-shaped curve. And it's defined by the mean. And for the mean, just like yesterday, we talked about just a tiny bit, the mean is represented as this Greek letter mu, and the standard deviation, which is another Greek letter sigma. And we haven't talked about standard deviation, but what I need you guys to understand about standard deviation is it just tells you how spread out or condensed the data is. So the smaller the standard deviation is, the closer all of the items in or the closer all the data is to the mean. And the bigger the standard deviation, the more spread out the data is. If you end up taking some statistics classes, you'll learn a lot about standard deviation, but today it's just going to be a number that we're going to use. All right, and then the area under the curve represents the probability. And the total area is equal to 1, or our probabilities are going to be as percentages. So the percentages are going to add to equal 100%. Okay. So in a normal distribution with mean mu and standard deviation sigma, what we're going to do on all of these, whatever the mean is, we're going to put it right in the middle. And approximately 68% of the data fall within one standard deviation of the mean. So if our mean is in the middle, one standard deviation to the left is this, and one standard deviation to the right is this. So 68% of the data is going to fall here. And if this is symmetrical, and it is, how much should each of those boxes be? How much percent should I write in each of those boxes if it adds to equal 68? Each of these boxes. It's not 34. So it's going to be 34 and 34%. Right? And approximately 95% of the data fall within two standard deviations of the mean. All right, so if the mean is here, We have 2 standard deviations to the left, 2 standard deviations to the right. So all of this percentage should add to equal 95. So this is 68. So that leaves 13.5% on each side of 34. All right, so all of those percentages add up to being 95%. And then approximately 99.7% of the data falls within 3 standard deviations of the mean. All right, so all of this was 95%. We add another standard deviation that is going to make up 4.7 more percent. So each one of those is going to be 2.35%. All right, and then that leaves a teeny tiny amount that is outside of 3 standard deviations that add together to be the 0.3% that we're missing. So each one of those is 0.15%. All right, now those percentages are going to be the same percentages that we're going to fill in on every single problem. And it's not something that you need to worry about memorizing. When we take our quiz on statistics, it's going to be like an open review quiz where we'll have all this filled in for you. So don't have to worry about memorizing. I just really want to know that you know how to set it up and then how to use it to answer questions. All right, so let's look at number 1. The weights of 50 football players are normally distributed with a mean of 178 pounds and a standard deviation of 8 pounds. So as soon as you guys see what the mean is, what we're going to do is go straight to the middle of the curve underneath, and we're going to label it with whatever the mean is, 178 pounds. So the mean goes right in the middle. All right, then we need to find the standard deviation. So this tells us our standard deviation is 8 pounds. So as we go to the right, what we're going to do is just keep adding 8. So each line you get to, you add 8. Now I still don't have my calculators back. I don't know what's happening, but you can use just a regular, you can use one of those blue ones or your phone to add 8 each time. So that's going to be 186 when I add 8, and then add 8 again, 194, and then add 8 again is 202. Exactly. So when we go to the left, like she said, we'll take that 178 and then we subtract whatever the standard deviation is, which is 8 in this case. So each problem that you do, those numbers are going to change just depending on what your mean is and your standard deviation. But the percentages are going to be exactly the same that we just filled in. So 34 and 34, and then 13.5, 2.35, and very outermost is 0.15.
So this inside number is going to be the same every time?
Every single time, yes. Now we're going to answer some questions about the situation with the weight of the football players. So A asks, what percent of players weigh between 178 pounds and 194 pounds? All right, so I'm going to use my highlighter. So between 178 and 194, these are the percentages that we're going to add to answer this question. So 34% plus 13.5% is going to be 47.5%. Right. And then B asked, what is the probability? So that's just another question that's what is the percent? So what is the percent and what is the probability are asking the same thing. So what is the probability that a player weighs at most 170 pounds? So there's a lot of at most and at least wording on these questions. So at most 170 means the most they can weigh is 170. So it's 170 or below. So we would add up these three percentages. I think you missed one of them. It's okay. It ends up adding to be 16%. Or maybe you just typed something wrong. So these two add together to be 2.5 plus 13.5 is going to be 16%. It's okay. All right. And then the next question, what is the probability that the player weighs less than 162 or greater than 194? So 162 or less plus 194 or less. All right. So these add up to be 2.5. These add up to be 2.5%. So that's going to be 5%. All right. Any questions so far?
How did you get the 47.5 again?
Okay, so A was 178 to 194. So I went from the 178 line to the 194 line and I added those together. All right. Redo B? Okay. At most 170 means 170 or less. So it's these three added, should add together to be 16%. Unless I'm doing something wrong. I think I'm right.
Okay. I thought you're adding like 34.
Nope, it's on the wrong side of the line. Gotcha. Okay, now D is worded differently, and we're going to do several different situations, and almost all of them have at least one like D, where instead of saying what percent or what's the probability, it asks how many. All right, so when it asks how many, you can't give a percent as an answer. We still need the percent, so let's look at it. We want to know how many players are between 170 and 186. So you're right. It's these right here. That is going to be 68%. That is not going to be the final answer, but we have to have that to get the final answer. So if we want to know how many players make up 68%, we have to go back to the problem where it says there's 50 total players. And we're going to multiply that by 68%, but we can't multiply it by 68 because that's going to be way bigger than how many players you have. So what do you guys think we're going to multiply it by? 0.68. So 68% as a decimal, you move that over two places. You basically divide it by 100. So that should be 34 players. Now, if you're answering these questions about people and you end up with like a partial person, just go ahead and round up to a whole person. There's one about like GPA, then that's fine. That can be a decimal. Or actually, no. Just kidding. Pretty much it's all people or phones. You can't have a partial, one of those things. So if you do get a decimal, just round on up. All right, so we're going to skip several and we're going to go to number 4. So it's a brand new situation, same curve, but we're going to put different numbers underneath. So Ms. Fuller recently tested her 120 keyboarding students to see how many words per minute they can type. The results were normally distributed with a mean of 45 and a standard deviation of 6. So what number is going to go in the middle? 45. Very good. And then as we go to the right, we're going to add 6 each time because that's the standard deviation. And as we go to the left, we're going to subtract 6 each time. And then we are going to fill in the exact same percentages that we have done each time. So 34, 34, whoops, 13.5 on each side of that, 2.35, and then 0.15. All right, so let's look at these questions. All right, A, about how many students can type at least 39 words per minute. Okay, so this is a different wording. So we had at most, this time we have at least. So at least means that the least that they type is 39. So it's 39 or more. So if you guys wanted to save some time, this bell curve is symmetric. So this whole half over here is 50%. So since we're using this whole half, we can take 50%. And then what would we need to add to it?
13.5.
Oh, no, 34. So this whole half is 50, and then I need 34 more percent. I know that looks kind of crazy. So we're doing at least 39. So I know from this is all 50% because it's half of the curve, and then plus 34 more. Or you can just add up all the percentages. I want you to do what you feel comfortable doing. It's 84%. Now be careful that you answer the question. So the question is how many students? And so I know that there are 120 students that we're looking at. So we'll take that and multiply it by 0.84, which is going to give us 101 students. Okay. It is from here.
The keyboard.
Yeah, 120 keyboard students. Okay. And then B, about how many students can type within 1 standard deviation of the mean. And that's worded weird also, or it's different from what you're kind of used to. So here's the mean. I didn't mean to use that. Here's the mean. 1 standard deviation away is 1 standard deviation to the left and 1 standard deviation to the right. So this is what we're adding. It should be 68%. So it's 1 mark on each side of the mean is 68%. And then it's asking again how many students. So we would multiply. Okay. And then the last question says that students need to be in the top 2% in order to be eligible for the national typing competition. If Carla can type 56 words per minute, is she eligible? All right. Now, 56 isn't one of our numbers underneath, but I know 56 is going to be about right here. Is there any way that is in the top 2%?
No.
No way. Because there's definitely at least 2.5% ahead of her, plus some others. So, no. Okay, we're going to do one more, and it's the very last question. So, on the majority of these, you have a curve already drawn, and you just kind of fill it in. On the last two, you're going to have to draw your own little curve.
we're not gonna do any of that tomorrow.
The other ones are going to be your homework. All right.
Might be like, ones that are like more to the left and more to the right. Not like the standard deviation. Like the positive. The
The ones we
positive
do
skewed and the negative.
Oh, you're not going to have, we're not doing anything with positive or negatively skewed. That's just terminology that you don't really need. It might come up again in your statistics class if you take one. But all right, so for number 10, a grade point average, or the grade point average of students at Lakeview High School are normally distributed with a mean of 3.1 and a standard deviation of 0.3. If there are 1,800 students enrolled at the school, approximately how many have a GPA between 2.5 and 3.7? All right, so we're going to draw our own little curve. I'm going to let the line down there be like the number line. And then just try your best. I'm kind of wobbly when I draw it. All right, and I know that I want to put the mean in the middle, so I'll go ahead and do that. Now, I'm probably not going to fill in everything on this because I'm only answering one question, so I'm just going to fill in what I need. Now, I know normally there's 3 lines on each side, so I'm just going to go ahead and draw them. They don't have to be beautiful. All right, so the 2 numbers I'm looking for underneath this line are 2.5 and 3.7. So when I get to those numbers, I'm just going to stop. So I know my standard deviation is 0.3. So I'm going to add 0.3 until I get to 3.7, and then I'm just going to stop. All right, and then I'm going to subtract 0.3 until I get to 2.5, and then I'm going to stop. Now, anything outside of that, we don't care about. So I'm not going to fill in my percentages there either. I'm just going to fill in what I need. It won't hurt if you fill in more than you need, but let me zoom in a little bit. Okay, so between 2.5, this is really messy. 2.5 and 3.7 are all those percentages that add up to be 95%. Now, I don't think that's going to be the answer to the question, but we can use it in just a second. Okay, so we want to know how many. So we're going to take the number of students at this school, and we're going to multiply that by 95% as a decimal, and that's going to be 1,710 students. What questions do you guys have? Okay, so what I want y'all to do for your assignment is just go ahead and do the ones we haven't done yet. I think you should be good on time.